Okay, today is 26th August 2020, and we were discussing in the last class on MIG, and we will continue from there. Now, in last class, we have discussed different variables in the process. Today, we'll discuss about the shielding gases. Those are used in MIG. Okay, shielding gas used in MIG. Here, the basic function of the shielding gas is to protect the molten metal and the electrode end, which is very heated, against the atmospheric contamination or oxidation. Okay, argon is used for Al, aluminium, magnesium, copper, nickel, Ti, and helium is used for also aluminium, magnesium, Cu, and CO2 is used for mild steel. Okay, now the major shielding gases are these. Now the argon is the principal inert gas which is used to non-ferrous metals. Okay, argon basically used to non-ferrous metals. On the other hand, helium is used to intercept the porosity. So if we use helium, it can work against porosity, and it provides better arc stability. So it decrease porosity, better arc stability can be found, and CO2 is used because of its low cost. It is very low cost and capable of producing good weld, producing sound weld. Okay, now so if we draw a chart, metal, gas used, and gas effects. So if we weld aluminium, we use argon or a mixture of argon 25% and helium 75%, and its effect is helps to remove oxides that are produced on the surface. Plus, as because there is much helium, porosity problem can be neutralized. Okay, if we weld mild steel, then we will use CO2, and it affects low spatter with comparing other gases. So it is low spatter and the cost is also low. For magnesium, we use argon, and argon helps to remove sorry surface oxides. Now stainless steel we use 99%, 98 to 99, 95 to 99%, most of the cases He, and rest oxygen. So oxygen helps to stable the arc and reduces undercut defect. On nickel, either argon is used or argon plus helium is used. Okay, the ratio changes depend on the requirement and the labor beside this. Argon can be used 25 to 75%, and depending on the argon, He can be changed. This helps the metal helps to control metal fluidity and reduces undercut and provide good welding bit. Okay, so these are the reasons why we choose shielding gas, and these all the effects has been found out from the experiments. Now, different type of metal that can be welded by MIG. Different type of metal that can be welded by MIG. So carbon and low alloy steels. Okay, stainless steels. Number three, heat resistance alloy like titanium, magnesium alloys, copper alloys. Number six, aluminium and its alloys. Number seven, high strength low alloy, HSLA. You need to remember this term, high strength low alloy steel. So these are the severe metals that can be welded. Now, why we choose MIG? What are the advantages? Advantages of MIG. What are the advantages? With compared to other similar welding processes, less spatter can be achieved. Number two, MIG is faster than MMAW, than TIG, and deep penetration can be achieved. Number four, no use of flux during welding process. So flux need not use need not to be used. Number five, process can be easily mechanized. Number 6, the quality is high and minimum defects are seen in this type of welding. Number 7, large deposition rate can be achieved. Number 8, high arc travel speed reduces distortion. Okay, so these are the advantages. Now we will discuss about limitations. Limitations are: number 1, the equipment is more costly and complex also. Number 2, trained or skilled operator required, as because before the welding starts we need to set the wire feed rate and we need to set the gas flow rate and we need to provide a proper uh, gas pressure. So that's why skilled operator, experienced operator is required. Number 3, process is not economical, because you need to buy wire spools and you need filled gas cylinders from time to time. So this is of course not economical. Number 4, all type of material cannot be welded. So then its applications are: number 1, welding aluminium, copper, magnesium, nickel and their alloys. Number 2, in aircraft industry, pressure vessel industry, ship, shipbuilding industry, uh, these are required. MIG is required. For manufacturing of refrigerator parts, MIG is required. Number 4, railroad industries, and 5, in transport industries also. These are used. This MIG is used. So what are the features that can be seen in MIG? It is one of the best way to replace TIG and SMAW and submerged arc welding SAW. Number 2, self sorry, self adjusting arc is achieved. Number 3, MIG uses constant voltage power source and short circuit current is very high. Number 4, self adjusting arc voltage directly proportional to the gap between wire and workpiece. And number 5, wire feed rate controls the burning off of the wire. Okay, so how the metal get transferred from the electrode or the metal wire to the workpiece. So there are different modes of metal transfer. Different modes of metal transfer. Number 1 is spray transfer. Number 2, global metal transfer. Number 3, deep transfer. Number 4, pulse metal transfer. This pulse metal transfer occurs when pulsed current is used. Deep transfer means the metal wire is dipped into the molten metal pool. And spray is, transfer occurs as spray. Okay, now we'll discuss difference between MIG and SMAW. What are the difference? So in such case, that whenever it called the difference, you need to make two columns, and you will write here electrode does not need to change. Here electrode need to change. Here in MIG, where spool to be changed. Number 2, no stage of wear. Here wastage of electrode is seen at the last. There are some portion which is to be, you know brought out from the electrode holder. That portion is waste. Number 3, bare electrode is used, or bare wire is used, and here the flux coated electrode is used, and in MIG there is no flux to be used. Number 4, MIG is always, most of the cases, DCEP, that means direct current electrode positive. And here DCEP, DCEN, AC, all can be used. Here others are also used, but DCEP is the uh, most used method. Number 5, this is a semi-automatic or automatic. Automation can be done in MIG, and this is a manual method. These are very important questions. Any questions till this point? Now, if we use CO2 and work with CO2 MIG welding, this CO2 dissociates into CO and produces 7760 degree centigrade, and this forms CO and as well as iron oxide, because we use CO2 in most of the cases in mild steels. If we use argon He, then we get more spatter. Now, welding equipments, MIG, equipments. The equipments are power source. Sorry guys. I need to disconnect. Just wait 2 minutes. I need to answer a call. হ্যাঁ স্যার ক্লাসে আছি তো। হ্যাঁ হ্যাঁ Okay, so number 1, MIG equipment is power source. Number 2 is shielding gas. Number 3, wire feeder mechanism. Number 4, welding gun. Number 5, cables and hose pipe for gas And if the electrode need to be cooled, then for water also, and some other uh, accessories like uh, gas regulator, flow meter, etc. Now we discuss about power source. In MIG, constant potential DC power source, and uh, this can be called welding generator or transformer of constant voltage type. So if uh, we require DC, then we take DC constant voltage type, or AC constant voltage type. Now these are similar with submerged arc welding. The same power source can be used in submerged arc welding also. Okay. DCRP gives you stable arc, and smooth metal transfer. If you use DCSP or AC, then there will be problem as arc becomes erratic and unstable. Now the shielding gas is kept in cylinder at a pressure of 120 to 140 kg per centimeter square. You have to use regulator, and that brings pressure of gas supply about, no 16 to 20 kg per centimeter square. Might be little more or less, but around that 20 kg per centimeter square. That's why the regulator is required. So we need to get into the working range. If we use CO2, then the advantages are as such for CO2 MIG welding: higher welding speed, number 2, deeper penetration, number 3, higher metal deposition rate, number 4, better mechanical properties, of the joint, number 5, the low cost CO2. So process is more economical. But there are limitations too. CO2 MIG limitations. Number one, CO2 is responsible for harsh arc and high impact property in welding joint cannot be achieved. Okay, so these are the points you need to remember. I think you can feel that this is a little more uh, depth than the MIG you have learned in your second year. Okay, with this topic, we will end the MIG and we will forward to TIG. So now we will discuss on TIG, tungsten inert gas arc welding. So the method or the working principle is quite similar. This is your gas cylinder. This is your regulator and flow meter. This is your power source. This is workpiece. This is tungsten electrode, and here there are channels for water to circulate. These water channels is used to cool down the electrode and the holder. So water goes in, cool water goes in and cools the welding gun and the electrode, and then the hot water comes out, goes to cooling tower or river or some any other place, then again cools down and fresh water, fresh cool water comes in with the inlet. So this is the basic working principle. There is a power source. This is the control unit. Here we need to set the gas flow rate as well as the power output. So this power and this gas goes inside the controller, and then it goes to the torch by means of cables. So this is hose pipe for gas flow. This, this, and these are cables, and this is the electrode, or you just call it T gun. Inside it there is electrode holder and the water jacket. So water can flow through it and cools the electrode so that the electrode does not wear out easily. And the tungsten is used because of the heat resistance uh, property. It actually conducts heat. That's why it can withstand more temperature. Now, the electric arc is struck between the non-consumable electrode, tungsten electrode, and the workpiece, either by touching with scrap metal or the workpiece, or the arc is started by high frequency pulsed current. First we take the electrode, then we electrode which is having no high pulsed current, high frequency current, then we get the electrode near 2 to 3 of the job, and because of the high frequency current the arc starts. The air path gets ionized and arc becomes stable. Now if there is no gas flow, then the arc will not form because the air will not be ionized. So first initially you need to transfer the gas. So when you turn on the gas, then you turn on the current, then you take your electrode gun in such a way so that the tungsten electrode can touch the molten metal. Do not touch, they get into a distance of 2 to 3 very very close. Then because of the high frequency current, the air flow or the shielding gas flow path from the electrode to the workpiece gets ionized, and thus arc gets start. And AC and DC both power source can be used, and the electrode dia might be 0.5 to 6.5 depending on the current required. If high current required, then we use more diameter. If we go for lower current, then we go for lesser diameter electrodes. So 0.5 to 6.5 dia is available, and the current is 5 ampere to 650 ampere is used. And if the water I mean if the this is welding current, if the welding current is higher than 150 ampere, water cooling is must. No air cooling will work then. After 150, water cooling is must. So water goes inside the tungsten uh, electrode gun, cools the electrode and the electrode holder, then comes out. So up to 150, air cooling will work. Okay, now we go for the equipments used. Equipment used in TIG. So first of all, we need welding torch, tungsten electrode, and you may need filler materials or filler rods also. Then you need power source, high frequency unit, DC rectifier, and cables. Number 3, we need inert gas or shielding gas. So inert gas for shielding purpose, pressure regulator, and flow meter. Number 4, cooling water supply. Number 5, gas and water solenoid valve. These are required. Now today we'll stop here